All right, so today's lesson is lesson 11.3, areas of circles and sectors, and we're also going to talk about a segment of a circle. So the first thing that you need to remember is the area of a circle. Formula for that, pi r squared. Most often we leave our answers in terms of pi. I am totally fine with that. So when you look at your homework for today, I'm probably going to make sure that all of the answers have, regardless of what the directions in the book say, I'm probably going to have you leave all your answers in terms of pi. I'll leave you some specific directions for that. I need to read all the questions. So our first example is about an archery target. So it says that you have a circular archery target that's yellow, and it's a 2-foot diameter. And then it says that the center, the bullseye, is red, and it has a 6-inch diameter. So I want you to think in terms of radius, first of all. So if the whole entire target has a 2-foot diameter, that means that the radius is 1 foot, which is the same thing as 12 inches. And then the bullseye has a radius, if it has a diameter of 6 inches, that means it has a radius of 3 inches. Now, if I am going to leave my answer in terms of pi, I want to make sure that my units are the same. So I'm going to use inches for both. So we're asked to find the area of the yellow region, and I know the notes say to round your answer to the nearest whole number, but we're going to just leave our answer in terms of pi. So, and then we'll get a whole number, I guess. So anyway, we're going to take the area of the large minus the area of the small. So pi r squared, so 12 squared times pi minus 3 squared times pi. That equals 144 pi minus 9 pi, which is about 135 pi. Inches squared. Now, if I wanted to turn that 135 pi into an actual number, I get 424, about 424 inches squared. All right, we also have the area of a sector. So the area of a sector is a proportion. Think about how we solved for arc length of a circle. That was a proportion comparable to circumference. Well, the area of a circle is also going to be a proportion comparable to the area of a sector is a proportion compared to the area of a circle. So if you think about the area of the circle, pi r squared is to 360 degrees as pi r squared is to whatever your theta is that you're looking for. Okay, and remember theta is just a degree. So we're going to find the area of sector ABC. So that's this guy right here. We're finding this shaded in region. And we're going to leave our answer in terms of pi. So we know that the radius is 6. So I'm going to say 6 squared, which is 36 pi, is to 360 degrees as we don't know the area of the sector. We'll just call it X is to, I kind of shaded over that, but you see that the theta is 100 degrees. And then you just cross multiply. So 100 times times 36 is 3600 pi equals 360x. Divide both sides by 360. And I see that 10 pi equals the sector. All right. Let's do another example for that kind of question. I guess it is. Is that our last example? Okay. So the last thing I want to talk to you about is a segment of a circle. And so a segment of a circle, if you think about a circle, a segment is made from a chord of a circle, and it's the shaded region that bounds the outside edge of the circle and the chord. The way that we want to think about this is that really a segment of a circle is actually a sector minus the area of a triangle. So if I were to subtract the area of the triangle, what I have left is the segment of the circle. You only have one question like this on your homework, and I actually had to add it because it wasn't in the book. So we're going to find the area of the shaded segment, and we're going to round our answer to the nearest tenth. So the first thing that we want to do is find the area of the sector. So let's see. I know that the radius of this circle is 24. So 24 squared pi over 360 equals, we don't know the area of the segment, or sorry, of the sector. We don't know the area of this, but we know that theta is 120. And I'm going to give you a cheat, actually. You see that to go from 360 to 120 is divide by 3, so you can actually do that. I know that you guys are smart enough to figure that out. So 24 squared is 576. If I were to divide that by 3, I would get 192. So the area of the sector is 192 pi. So let me again say what I did. I took 24 squared, which is 576, and I divided that by 3, and I got 192. Okay, so we have this first portion, the area of the sector, 192 pi. Now we need to figure out the area of the triangle. Now this is a little tricky. It's been a minute, but we're going to use some right triangle magic. So I'm going to draw this triangle that you see, and you notice that this is a central angle of 120. Well, I know that the radius is 24. That means that both of these outside measures are 24, and I know that if I drop this fabulous perpendicular, I have cut the angle in half, which means this is now 60 and this is 30. So I have a 30, 60, 90. So I'm going to draw it this way. So this angle right here is now here. This segment right here, the hypotenuse, is now here. And I'm looking for x and x root 3. Well, I know that 24 represents 2x because I remember that from special right triangles. So if 24 is equal to 2x, that means x equals 12, and that means that x root 3 is actually 12 root 3. Now let's look at all of those measurements. Let's put them inside of here. So x is 12, and this is 12 root 3. Which means that this whole thing, this entire piece, is 24 root 3. And I'm finding the area of a triangle. Area equals 1/2 times the base, 24 root 3, times the height. All right, well, half of 24 is 12. 12 times 12 is 144. So the area of the triangle is 144 root 3. So if I want to find the area of the segment, I could take the area of the sector minus the area of the triangle. And I'm just going to put those into my calculator. So I have 192 pi minus 144 times the square root of 3. And that equals, are we rounding to the nearest tenth? 353.77, so about 353.8 feet squared. All right, so I am going to post this, and I'll put some directions in your assignment to let you know which answers I want you to solve to the nearest 10th or 100th, and which ones I just want you to leave in terms of pi. The other thing is I have a Zoom scheduled for us. I know that you guys are not big fans of that, but Mr. Dudley really does want us to get together with all of our classes at least once a week. So if you have other teachers that are offering Zooms for you, it's because they really want to see your smiling face. Mr. Dudley wants us to participate. So your Zoom is scheduled for Friday at 10 a.m. It is on the Canvas calendar. Make sure if you have any questions, you message me. Thanks.